Hello everyone. Today let's solve the problem 55 jump game, right? So what the question states here, we are given an integer array nums. You can clearly see here, right? So we are given an integer array nums. For the from index I, we can jump up to nums of I steps forward, right? From the index I, we can jump up to index nums of I steps forward means we'll be starting from here. We have been given value 2. We can just jump one step or the two steps. Maximum two steps we can jump, right? So we have to start from the first index itself, right? So we can jump one or maximum two steps, right? So see, we can either jump here one step. So next we can jump one or two or three steps ahead. So that's what, right? So that's what the question states here. We have to return true if we can reach the last index, right? Otherwise we have to return false. Again, we have to return true if we can reach the last index, otherwise we have to return false, right? So simple. So let's consider the first example here. See, we have 2 here. Let's do one thing. Let's take one step here. Instead of the two, we can take one or two, right? Maximum we can take two steps. We'll take one step ahead. So from here, this is index one, this is zero based index, right? From 0 to 1 we have jumped. So from the first index we can go to this one, fourth index directly, the last index. See here, three steps we can jump, right? So 3 is the value, so we can jump three steps ahead, 1 2 3. So we'll end up at the last index. So this is possible. In this case, we have to return true, right? If it was not possible, then we had to return false, right? I hope this part is clear, man. This is fine. Now, this is fine. Let's come to the second example. Now we have the nums array 3 2 1 0 4, right? So here, let's jump three steps ahead, 1 2 3. So we'll end up at 0. So 0 steps, it is not possible to go ahead at all, right? So now we'll stop at this one is false basically. So it is not possible. So if suppose if we jump two steps, so we will end at one, and one step again we will end up at zero itself, right? We'll be moving one step, we will end up at zero itself, again zero. If we take two steps, if we take three steps, then also zero. If we take two steps, then also zero. What about this one? If we take one step, right? So now we will jump from 3 to 2, right? So 3 to 2. So here then we will take two steps. Suppose if we take two steps, so again we'll end up at 0. So if we take one step, then also it is 0. If we take one step, one step, then also see here one. Now again one step, so again one we will end up to 0. 1 1 1. This will also end up to the 0, right? So it's not possible at all to reach the last index, right? In this case, it's not possible to reach the last index at all. So in that case, what we will do, we will return false. In that case, we will return false. Simple. Let me delete this one, man. Yep, this is simple, right? So this is fine, man. Uh, Now what we will do, let's do one thing. Let's discuss the approach followed by the complexities, and then let's write the code, right? So as usual, first let's discuss the complexities, right? Sorry, this one approach, right? So first thing I want to tell you here is we will be going with a greedy approach, man, right? So we will be going with a greedy approach. Simple. This just keep this in mind. Not the simple. So just keep this in mind. We'll be going with the greedy approach. So first, what we will do, let's consider this first example itself, right? So this gives true. So this will be easier for us, right? So let's consider first example here. So we will keep a variable max here. Max in the sense, I'll just consider mx here. So this one is the farthest index that is reachable so far, right? So initially, we will set this one to 0. We'll be considering max, variable max, mx I have written, right? So this one is nothing but this is equivalent to the farthest index that is reachable so far, nothing but initially it will be kept at 0, value 0. So now at the index 0, so what we will do, we will be going with the max equals this one, max of 0, max of 0 and the value, right? So this will be 0 comma current this one current index plus the value, right? So this one will be 0 comma 0 plus 2. So this one, this is nothing but 2 here in this case, right? So we have considered first. So this is max of current index comma current index plus the value at that particular index, right? So 0 comma 0 plus 2. right, in simple terms. So this will be 2. So we can reach up to the index 2 here. See here, 0 1 2. So we can reach up to the index 2 here, right? So this is possible. In this case, this is possible, right? So we can reach up to the index 2, right? So this is fine. Now we can reach up to the index 2, possible. I'll just write here, possible, right? So we can reach up to the index 2. So now what we will do, we will move to index 1. So this one, 3, we will move to index 1. Now what we will do, since 1 is less than or equal to max, right? Mx, now we have the mx value as 2, right? So we have now currently mx value we have is 2, right? From this one, max we are going with this one, current index comma current index plus 2 we are going, current index plus the value at that particular index we are going. Current, this one max value is 2 currently, and we will be moving to the index 1, next index, since 1 is less than or equal to max, right? So since 1 is quite obviously less than max, so 2, basically the value 1 is less than 2, right? So max, what we will do, max now, this one, let me write it over here, max, this one will be going with max equals, sorry, just give me a second here, max equals, so we will be going with a max of uh, this one, the previous value, nothing but the 2 comma, what is the index, first index 1 plus, so this one, what is the value we have, 3, what is the value we have, 3. Initially we will be considering this 0, this current value, 0. So this is nothing but the index, this is nothing but the current value, and this is nothing but the value at that particular index, right? So now the value at the particular index is 3, index is 1, and this one is nothing but the previous mx value, right? So the current value of the mx is 2, right? So 2 comma 1 plus 3. Now this will be 2 comma 4. Max of 2 comma 4 is quite obviously 4, right? So 4, 4. So now we have got 4. Max is greater than or equal to last index. We will check whether max is greater than or equal to last index, right? We will check whether max is greater than or equal to this 2. Let me write this one, index itself. This is fine. Now we don't need that 2. So this one, index. So we can reach the end here. See, we have the value 4 at the last index, right? Or the index is this one, fourth index is the last index, right? So now we have the value 4, now we have the value for nothing but the last index, which is equivalent to the last index, so we can reach the end. So since we can reach the end, we have to return true in that case, right? So we have to return true in that case. So what we will do, after getting the value 4, since we are able to reach the end, we will return true here in this case, right? So the output that we got here is true, which is equivalent to the output that they have given for the this one, example 1 within the question, right? So if at any step I is greater than max, then we are stuck at and we will be returning false. Try for the example 2. So here we will get I greater than mx or the max, right? So we will be stuck, we'll get stuck and we have to return false in that case. I insist you to try out for the example 2, right? So I have shown this one for the example 1 approach. So we have discussed example 1, right? So within the approach we have considered example 1 basically. So this is fine. Now the output that we got here is true, which is equivalent to the output that they have mentioned for the example 1. So our approach works absolutely correct in this case, right? So as we are completely familiar with the approach now, let's do one thing. Let's quickly discuss the complexities, right? So what will be the time complexity, man? Accordingly, here the time complexity would be quite obviously we are going with a greedy approach, right? So whenever greedy, the time complexity would be big of n. So why it would be big of n? Because most of the times in greedy, we'll be going with a single pass through the array, right? So that will lead to big of n. So the time complexity would be big of n. This is fine. So this is fine. So what would be the space complexity here? The space complexity would be big of 1. So why the space complexity here would be big of 1? Because we will be going with a constant extra space only for the few variables, right? So we'll be considering only few variables. Meaning, so we'll be going with a constant extra space. So overall space complexity would lead to big O of 1. So the time complexity and the space complexity for the code that we'll be writing in the future would be big O of n and big O of 1 respectively. Right. So now as we are completely familiar with the approach and the complexities, we are good to write the code. Let's start writing the code. So initially, we'll be making use of the length of the nums everywhere. So I'll just assign that one to the variable n here, so that I don't have to write a length of the nums everywhere. Right. So this is fine. Nums dot length everywhere. Right. So now, as usual, as we had discussed in the approach, let's consider max variable. This one, initially, what we have to do, we have to initialize this one to 0 as per the approach. Now let's iterate through the each index up to n minus 1. That's what we need to do, right? So accordingly with the approach, so this one is int I equals 0, so this one has to be I less than n, and let's increment this one. This is fine. Now within the for loop, what we need to do, if the current index I is beyond what we can reach, then we are stuck accordingly with this one approach that we discussed. If the current index I is beyond what we can reach, then we are stuck. And this one we have to return false. I said you to try out for the example 2. In that case, we will be getting I greater than mx or the max, right? So here, what we need to write, we can just implement in this way. So if I greater than max, then we have to return false. Then we have to return false. This is fine. Now let's do one thing. We have to update the farthest reachable position using the jump from I. So if you remember in the approach, we went with mx equals math dot, this one max of current this one value, comma this one particular index plus nums of I, or the iterated value of the nums, the value that is present in that particular index, right? So the same thing, let's write it in the form of code. So this one will be mx equals math dot max of this one will be max, comma I plus nums of I. So this is fine. Now we're just updating the farthest reachable position using jump from I. This is fine. Now if farthest reachable already reaches, or if it passes the last index, then we have to return true accordingly with the question. That's what they have asked in the question, right? So let's implement the same thing in the form of code. If mx greater than or equal to n minus 1, then what we need to do, we have to return true in that case. What we need to do, we have to return true in that case, right? So this is fine, man. Now if the loop completes, then we are not left with any stuck, we are not stuck at anywhere, right? So if the loop completes, then we are not stuck at anywhere. The last index is reachable in this case, so in that case we have to return true. So let me give here return true, right? So this is it for the code, very simple, right? So let me format the code once and let me hit the run button, man. Yep, you can clearly see here the sample test cases are getting passed. So let me hit the submit button quickly. So I hope this works for all the test cases, man. Let's see. So yeah, you can clearly see here all the test cases are getting passed. Means the code works absolutely correct in this case, right? So I hope whatever the code that we have written is completely clear, or this one, the solution part is completely clear along with the approach and the complexities. For now, this is it. Thanks for watching, guys.